Hello, math learners! Our lesson for today is about graph of inverse functions. The learning objectives are you're going to construct the table of values, plot the points in the Cartesian plane, and graph the identity line, the function, and its inverse. This is the Learning Pocket concept map, and we are going to concentrate only on the graphs of inverse functions. Let us have the characteristic of the graph of inverse function. The graphs of y is equal to f of x and y is equal to f to the negative 1 of x are symmetric with respect to the line y is equal to x. Thus, the graph of the inverse function, or f to the negative 1 of x, can be obtained from the graph of f of x by switching the positions of x and y values. And this is equivalent to reflecting the graph across the line y is equal to x. Let us have examples of the graph of functions and its inverse function. The first one is showing the function f of x is equal to 2x plus 1, which is a linear function, this blue line. And the inverse of the function is f to the negative 1 of x is equal to x minus 1 over 2, this red line here. The second example is given f of x is equal to x squared where x is greater or equal to 0. Take note that f of x is equal to x squared is a quadratic function, and the graph of a quadratic function is a parabola. And that is why we restrict the values of x into greater than or equal to 0 in order to have a one-to-one function. And the inverse is f to the negative 1 of x is equal to the square root of x. We have to restrict also the values of x. Let us have now the steps in sketching the graph of a function and its inverse. First, you have to graph the identity line. Under this, we have to construct the table of values of the identity line y is equal to x. Then plot the points in the Cartesian plane and connect the points with a dotted line. Then number 2, graph the function. Still, under this, we have to construct the table of values of the function, plot the points in the Cartesian plane, and connect the points. Then number 3, you have to graph the inverse function. Still, you have to construct the table of values of the inverse function. You can use the values in step 2 and switch all values of x and y. Then plot the points in the Cartesian plane and then connect the points. Take note, after sketching the graph, you have to label the graph completely. Sketch the graph of f of x is equal to 2x plus 1 and f to the negative 1 of x is equal to x minus 1 over 2. First, you have to verify if they are inverses of each other by applying composition of functions. So, these are the steps to use the format of the given function and replace x by the given of the second function. So, the solutions, we have f circle f to the negative 1 of x is equal to f of f to the negative 1 of x. And following this form, that's 2x plus 1, change x into x minus 1 over 2, which is the given of the second function. Then plus 1. Then simplify, you cancel 2 and 2. What is left is x minus 1 plus 1. Negative 1 plus 1 is 0. The value of f circle f to the negative 1 of x is x. And for the second composition, we have to take f to the negative 1 circle f. So, the steps are, you have to use the format now of the second function and replace x by 2x plus 1. So, the solutions are, first, you have to write f to the negative 1 circle f of x, and this is the equivalent expression f to the negative 1 of f of x. And you have x minus 1 over 2. Change x into 2x plus 1. Then minus 1 over 2. Then simplify. Positive 1 minus 1 is 0. What is left is 2x over 2. Cancel 2. The answer is x. Therefore, f to the negative 1 circle f of x is equal to x. Then, the answers are the same. So, we can conclude that they are inverses of each other. Then, we are ready to graph now. So, step 1, graph the identity line y is equal to x. So, under step 1, you have to construct the table of values of the identity line y is equal to x. So these are the values of x, negative 2, negative 1, 0, 1, and 2. And since they are identical, then y is also negative 2, negative 1, 0, 1, and 2. Take note that the coordinates of the points are identical. And then you have to plot the points in the Cartesian plane. You have negative 2, negative 2, negative 1, negative 1, 0, 0, and so on. And after that, you have to connect the points with a dotted line. So, it would be like this. Plot negative 2, negative 2, negative 1, negative 1, the point with coordinates 0, 0, the point with coordinates 1, 1, and the point with coordinates 2, 2, and connect with a broken line or a dotted line. So, this will represent the identity line y is equal to x. For step 2, you have to graph the function f of x is equal to 2x plus 1. Under this, you have to construct the table of values of the given function. So, the values of x are negative 2, negative 1, 0, 1, and 2. And the values of y, we have negative 3, negative 1, 1, 3, and 5. I will give you only one example on how to get the value of y. So, for example, at x is equal to negative 2, use the function, substitute negative 2 to x. So, 2 times negative 2 is negative 4 plus 1 is equal to negative 3. Then, plot the points in the Cartesian plane. Negative 2, negative 3, negative 1, negative 1, and so on. And then, connect the points with a line. So, let us plot negative 2, negative 3, the point negative 1, negative 1, the point with coordinates 0, 1, the point with coordinates 1, 3, and 2, 5. And connect with a line, that blue line there. And for the other solutions, you can do it yourself. Step 3, you have to graph now the inverse function f to the negative 1 of x is equal to x minus 1 over 2. Still, you have to construct the table of values of the inverse function. And all we have to do is to use the table of values of step 2, but we have to interchange or switch the values of x and y. So, in step 2, x is negative 2, y is negative 3. So, just interchange, x now is negative 3, and y becomes negative 2, and so on. So, I will just give you one example on how to get negative 2. At x is equal to negative 3, this is now the given function. Change f to the negative 1 of x into y is equal to x minus 1 over 2. Substitute negative 3 to x. So you have negative 3 minus 1 over 2. So negative 4 over 2 is equal to negative 2. That is why it's there. Even if you will not switch, the answer is really negative 2. Then plot the points in the Cartesian plane, starting negative 3 and negative 2. And so on until 5, 2. And then you have to connect the points with a line. Okay, let us start. There you have negative 3, negative 2, negative 1, negative 1, 1, 0, 3, 1, There, 5, 2. And connect with a line. There. So by this time, so again, you have to take note, just use the table of values in step 2 and switch all the values of x and y. And let's recap. So, in sketching the graph of the function f of x is equal to 2x plus 1 and f to the negative 1 of x is equal to x minus 1 over 2, first, you have to grab the identity line. Y is equal to x. There. And connect. Then graph the function. F of x is equal to 2x minus 1 using the points. And then connect. Then graph the inverse function by plotting the points. And connect the points. There. So this is now the graph of the function f of x is equal to 2x plus 1 and f to the negative of 1 of x is equal to x minus 1 over 2. The blue one will represent the function, the yellow one will represent the inverse function, and the dotted line, the red one, will represent the identity line. So the graph of the inverse function equals to x minus 1 over 2 is the graph of the function equals to 2x plus 1 reflected about the diagonal dotted line y is equal to x, which we call the identity line as shown in the figure. And then if you would like to identify the domain and the range, you don't have to solve for the values of the domain and the range. By inspection, looking at the function, you can assign all values of x as you extend the line. If the line is extended to negative infinity, you can use also the value of x. So that is why we have the domain is equal to the set of x such that x is the element of real numbers. And then for the range, still real numbers, because you can use also all the values of y going to positive infinity and all the values of y going to negative infinity as you extend the line. And also with the yellow line for the inverse. You can use all the values of x, positive infinity to negative infinity, from negative infinity to positive infinity. And then for the range, you have also, you can use also all the values of y. That is why for the inverse function, still the same, the domain is equal to the set of x such that x is the element of R, and for the range is the set of y such that y is the element of real numbers. Let us have example number 2. The graph of f of x is equal to x squared where x is greater or equal to 0 and its inverse. So by this time, you are not given the inverse, so you have to solve for the inverse function. So find the inverse of f of x is equal to x squared. So the solutions, given f of x is equal to x squared, first move, you change f of x into y, then interchange x and y. So from y it becomes x and from x it becomes y. Then apply the symmetric property of equality, just interchange the order. You write y squared here and then x here. Then extract the square root of both sides. You can cancel the symbol together with the square because square root of y will give you y to the exponent of 1/2. And when you square 1/2, it will give you 1. So that is why we only have y here later on. It's equal to the square root of x. And y is equal to the square root of x. This is now the inverse of y. Just change y into f to the negative of 1 of x is equal to square root of x. Then we have to verify if our answer is correct. So we have to take the composition of the two functions. Starting f circle f to the negative 1. So the first function is x squared. We have to follow the format. Then the second function is square root of x. This expression is equivalent to this. So we have x squared, change x into square root of x. Then cancel. Then we can have x. Let's try to find out if our answer for the next composition is still x. So we have to verify the inverse circle f. We have to follow the format of this one, and we have to replace x by x squared. So this expression is equivalent to this, and square root of x, and since we have to change x into x squared, that is why we have square root of x squared. Cancel, what we have is x. Therefore, the answers are the same. Then, we can conclude that they are inverses of each other. Let us have now the graph. Step 1, we have to graph y is equal to x. Construct first the table of values for the identity line y is equal to x. So, these are the values of x and the values of y. Still, the coordinates of the points are identical. And we have to plot the points in the Cartesian plane later. These are the points with the respective coordinates. And we have to connect the points with a dotted line. So, let us plot the points now. You have there negative 1, point with 0, 0, point with coordinates 1, 1, 2, 2, and 3, 3. And then connect with a dotted line. So this is our identity line, y is equal to x. And you have to see to it that you have to label the points with its coordinates. Step 2, we have to graph the function f of x is equal to x squared, where x is greater than or equal to 0. Meaning you have to restrict the values of x using only greater than 0 or equal to 0. So, construct first the table of values. So, you can use equal to 0. So, the first value here is 0. Then y is equal to 0. 0.5 is greater than 0. The value is 0.25. 1 is greater than 0. The value of y is 1. We can use 1.5, which is greater than 0. The value of y is 2.25. So I will just give you one example on how to get the value of y. So at x is equal to 0.5, f of x is equal to x squared. That's the given function. Replace x by 0.5, then you square. The answer is y is equal to 0.25. That is why if x is 0.5, the value of y is 0.25. Then plot the points in the Cartesian plane. We have 0, 0, 0.5, 0.25, and so on. So there are only 4 points. And then connect the points with a curve, because this is a parabola and we're only taking half of the parabola. So let us plot the points now. 0, 0, 0.5, and 0.25, 1, 1, and 1.5, 2.25, and then connect with a curve. There, it's only half of the parabola because we restrict the values of x. And for the other solutions, you can do it. And then do not forget to label the points. Step 3, graph the inverse function. F to the negative of 1 of x is equal to square root of x. So, construct the table of values of the inverse function. You still have to restrict the values of x. So, you have now 0 and 0. In step 2, this is 0.5 and y is 0.25. So, you switch the values. And also with this, it's just the same here because it's 1 and 1. And I will show you one example on how to get the value. Supposing x is equal to 0.25, so y is equal to the square root of x. Take the square root of 0.25, the value is 0.5. So here, 0.5. So even if you will not switch the values, it will still give you 0.5. Then plot the points. So there are only 4 points. Then connect the points with a curved line later. So let us plot the points now. 0, 0. There. 0.2505. 1, 1. And the point with coordinates 2.25, 1.5. And there you have the curved line. Take note, again, if you don't want to solve, just switch all the values of x and y in order to have your table of values for step 3. So let us have the recap in sketching the graph of the function f of x is equal to x squared, where x is greater than or equal to 0 and f to the negative 1 of x is equal to square root of x. So first, we have to graph the identity line. Then connect. Then we have to graph the function f of x is equal to x squared. Then we have to graph the inverse function using the points. And then connect with a curve. Do not forget to place an arrowhead here and here. And also for the identity line, label the y-axis with y, x-axis with x. So the graph of the inverse function, which is equal to the square root of x, is the graph of the function equals to x squared, reflected about the diagonal dotted line y is equal to x, which we call the identity line, as shown in the figure. This one. And there. The reflection is this one. The function f of x with the domain restricted to this interval notation 0 to positive infinity, or x is greater than or equal to 0. And restricting the domain will make the function 1 to 1. You can also identify the domain and the range. The domain is equal to the set of x such that x is the element of R, where x is greater than or equal to 0. And R is the set of y such that y is the element of R, where y is greater than or equal to 0. Let's inspect. So this is the graph of f of x is equal to x squared with the restriction. And then as you extend the graph, you can use only x is equal to 0 and greater than 0. And as you extend this, you can use all the values of y only, starting 0 to positive infinity. And for the inverse function, the domain is equal to the set of x such that x is the element of R, where x is greater than or equal to 0. And for the range, the set of y such that y is the element of R and y is greater than or equal to 0. This is the graph of the inverse function, and we are using only the value of x greater than 0 or equal to 0. And for the y, as you extend the graph, you can use only the positive values of y plus 0. Do you have questions? If there are no questions, then see you next time. Bye!